Hi, I'm Dr. John Argalaska. Many of you have asked me to record some guided mindful meditations for your use in your own time, the kinds of things that I do with my clients, with you, and with my classes at Antioch University at the start of every class. My guided mindful meditations are based on neuroscience, physiology. The resonant breathing that I do was known uh, thousands of years ago by monks in the Himalayas and in Asia. But what I do is not based on any monastic tradition. Not that that diminishes anything, but what it is based on is neuroscience and physiology, as I said. Um, Resonant breathing, breathing in at a rate of about 5 or 5.5 seconds and exhaling at about the same rate, um, has physiological effects on our circulatory system. When you inhale, your heart goes a little bit faster. That's a physiological, natural consequence of inhalation. When you exhale, your heart rate goes a little bit slower. Now, if your heart is pumping into a closed system, which it is, when it goes faster, your blood pressure is going to go up. We have an organ or organs in the major arteries of our body called the baroreceptor. The baroreceptor is there to regulate blood pressure. When it senses that blood pressure is going up when we inhale, um, it sends a message to the sinoatrial node of the heart to slow down. It takes the baroreceptor about 5 or 5.5 seconds to sense the fact that blood pressure is going up. The key to resonant breathing is to get the message from the baroreceptor to the sinoatrial node of the heart to arrive at the same time as you start your exhale. Because when you start your exhale, your heart rate goes down a little bit. Now, I'm not talking about heart rate over a minute or 2 minutes. I'm talking about interbeat intervals. So from one beat to the next beat, to the next beat, to the next beat. When you inhale, this interbeat interval gets shorter. And when you exhale, the interbeat interval gets longer. This is known as heart rate variability. We think of our heart as sort of like a metronome. It's not. Our heart changes in regard to the demands, our homeostatic demands. We all know that when we're sleeping, our heart rate slows down, and when we're active physiologically in exercise or whatever, our heart rate goes up. Well, we're talking about very tiny changes here in the interbeat interval, getting shorter or getting longer, and the nature of how smooth those changes are. So you inhale, your heart rate goes faster. Baroreceptor senses, oh my gosh, blood pressure is going up. This is because your heart's beating into a closed system. So if it's pumping faster, pressure goes up. Baroreceptor sends a response to the sinoatrial node of the heart. Hey, slow down, blood pressure is going up. You want that message to arrive at the same time as you begin your exhale, which also sends a message to the heart to slow down. Now, if this happens, what happens to the interbeat intervals and the changes in those interbeat intervals makes your heart rate variability smoothness become a sinusoidal wave, a nice up and down smooth arc. Normally, if you look at heart rate interbeat interval changes, they're jagged up and down, and that's normal. Everybody's heart rate variability looks like that, and it can be measured with electrocardiogram and other kinds of instruments as well. But when you are able to get your heart rate variability to be a sinusoidal wave, very smooth up and down, the distance between the peaks and the valleys, which is known as respiratory sinus arrhythmia or heart rate variability, gets larger. Stephen Porges, author of polyvagal theory, states that greater heart rate variability, greater respiratory sinus arrhythmia, which is measurable, is an increase in polyvagal tone. Excuse me, not polyvagal tone, simply vagal tone, the tone of the vagus nerve. The vagus nerve The ventral vagus nerve is responsible for affect regulation of organs above the diaphragm. So, in other words, if you are able to increase your heart rate variability, smoothness, you increase vagal tone, which in turn increases your ability to control affect. So, this is a physiological uh, manipulation that has a direct consequence on your subjective life experience, your ability to control affect. Um, it's a mind-body intervention that works in a very straightforward way. Now, that's part one of what I wanted to present to you, the relationship between inhalation, exhalation, interbeat intervals, respiratory sinus arrhythmia, and vagal tone. Part two is our brains have a limited capacity. Just as a computer has a processor that is limited, our brain has limited processor as well. And so in my meditations, I use multi-sensory imaging to imagery to try and get you to utilize as much space in that processor as possible. And when this happens, because that space is limited, you crowd out what I call left hemisphere chatter. That's the noise that we have in the background of our mind all the time. Who's going to pick up the kids? What are we going to have for dinner? What am I going to get my mother-in-law for her birthday? That kind of stuff that runs in the background all of the time. I try to help you to crowd that out by maxing out the processor of your brain by filling it with multimodal sensory images. That's part two. Part three is I offer suggestions. Now, when you do these meditations that I will have published on my website, it's best if you can recline and close your eyes. Two reasons. When you recline, alpha waves become more dominant in your electroencephalographic patterns. That's a natural consequence of reclining. Also, when you close your eyes, alpha becomes stronger. Now, all of the different brain waves are present all of the time in your electroencephalographic patterns. It's just that alpha becomes more dominant, becomes stronger when you close your eyes and recline. When you do resonant breathing, alpha and also theta tend to become a little bit stronger as well. So it's best to do these things eyes closed and reclined with a breath pacer. And those of you who have worked with me before know that I recommend getting a pacer on your phone. If you look up simply breath pacer in the App Store, you'll be able to find several of them. Some of them are free and you have to be inflicted with advertising, or some of them are $1.99, very inexpensive kinds of things. The timing of your breathing in these exercises is much more important than the depth of your breathing. If you breathe too deeply, you're liable to get hypocapnia, hyperventilation, which could make you dizzy. That's counterproductive in this exercise. So if you find yourself getting dizzy at any time that you're doing one of my meditations, you're breathing too deeply. Just stop and breathe normally. Okay. Also, don't do it with food in your mouth or when operating heavy machinery. So relax, lean back, close your eyes, and use what is called a belly breath. That means that when you inhale, your abdomen is allowed to protrude a little bit, opening your diaphragm. This allows a greater, deeper exchange of gases with the atmosphere and your lungs. You might want to put the pacer on your right over your diaphragm, right at the point where your ribs come together, right above your belly. And when you inhale, just lift your phone a little bit. And then when you hear the auditory cue to exhale, notice that your belly goes back down. So I've talked about three things, three reasons why my guided mindful meditations are based on neuroscience and physiology. One is we are exploiting the baroreceptor response, which is a natural response of the heart rate accelerating, the interbeat interval becoming shorter when you inhale and longer when you exhale. And this is an effort to get your heart rate in sync with your respiration so as to make the changes in your interbeat interval smoother. It's referred to as heart rate variability smoothness. When this happens, the respiratory sinus arrhythmia, the distance between the peaks and the valleys gets larger. Stephen Porges says that heart rate variability, which can be measured, is a measure of vagal tone. A good vagal tone is responsible, or the vagus nerve is responsible for affect regulation. So better vagal tone, better affect regulation. So I hope this explains to you sufficiently why the kind of guided mindful meditations that I have on my website are based on physiology and neuroscience. So do check them out. I'll have at least one on there for free, and the others will be by donation. Okay. Thank you. Take care.